Problem 4. When air expands adiabatically, that is without gaining or losing heat, its pressure and volume V are related by this equation. All right. Suppose that at a certain instant, the volume is 620. Volume. So V is 620. Pressure is 79. Okay. And is decreasing at 8. So pressure is decreasing at 8 kilopascals per minute. At what rate is the volume increasing? All right. You're told this relation. Okay. This is all happening with respect to time. So take derivative of both sides. C is a constant. So product rule, derivative of the first, second as it is, plus first as it is, derivative of the second. So that power comes down, reduces, and then you have a dv dt. This is a constant, so its derivative is 0. All right. We are told volume is 620, P is 79, dp dt is negative. Why is it negative? Because it's decreasing. All right. Plug in all those values and solve for V. That's all. Take the number to the other side and so on and so forth. Negative becomes positive. Notice, I don't even solve for this. I type it in as it is. Remember all the extra brackets you need. That's all. Last problem. A plane flying with a constant speed of 24 kilometers per minute passes over a ground radar station at an altitude of 16 kilometers and climbs at an angle of 35 degrees. At what rate is the distance from the plane to the radar station increasing 3 minutes later? Okay, this is a rather detailed picture, so let's go through it. So my plane is flying like that. Here is my radar station. So the problem starts, my plane is 16 kilometers above radar station and it is going 24 kilometers per minute. Okay, so after t minutes, this distance is 24t. The angle the plane takes is 35 degrees. So that's the horizontal here. All right, so far so good. So what is, this is 16, so opposite is 16. That is x, so opposite is also x. Y, this y is the height it has reached after t minutes. Okay. Now, question is, at what rate is the distance from the plane to the radar station increasing? So that's where my plane is. Here is my radar station. That distance is capital D. After 3 minutes. All right. So 24t is this distance because it's flying at the speed of 24 kilometers per hour, per minute rather. So after t minutes, it is 24t. Okay. Here I have a right angle triangle. So d squared is x squared, as that is x, this is x. X squared plus y plus 16 quantity squared. This angle is 35 degrees, but degrees, you need to convert it to radians. So 35 times pi over 180 radians. What do I know about x? Okay, so that's a right angle triangle, correct? So cosine of this angle adjacent over hypotenuse. In other words, x is 24t cosine angle. Y is 24t sine angle. Okay. Now, this is your d squared function. I'm going to simply open my d squared function completely. All right. Once I do that, x squared plus y squared, x squared plus y squared is 24t squared. That's simply Pythagorean. So that's all I'm using. X squared plus y squared is 24t squared. Now here is y. Y is 24t sine of your angle. So that's all I have done. Plus 256. So this tells me d is square root of all of this. All right. Now let's go back to d squared. And now, so that was only to find d. And now I want to find derivative of d with respect to time t. I can take derivative of this, or I can take derivative. This is easier because there is no square root involved. So 2d dt is 2. So notice 24 squared, right? And then t squared. So that's 2t. Here, there is a t only over here. So they are all constants. They all survive. Derivative of t is simply 1. Derivative of constant is 0. So divide by 2 throughout to get rid of the 2. Divided by 2, divided by 2, and divided by 2. Okay. Now I can divide by d to find dt. D, remember we had solved for d. Okay. That goes in the denominator. Okay. So question is what is dt when t is 3 minutes? So wherever I see t, I'm going to place 3. There are only 3 places, and that's what I have done. I have placed 3 wherever I saw t. And you have the correct answer. All right, notice. Make sure your expression looks like that. All right, so this completes section 2.8. Next video will cover section 2.9. Until then.